All right, so what we're going to do now is we're going to use our Pythagorean theorem to find something else out. As we already learned, Pythagorean theorem can allow us to determine the side or the hypotenuse of a right triangle using the leg squared plus leg squared equals hypotenuse squared theorem, or it actually can allow us to verify a triangle is right if we can show that the square of each leg, the sum of those squares, is equal to the hypotenuse squared. But what if it happens where the square of both legs is not equal to the hypotenuse squared? Well, then we don't have a right triangle. But we can also learn, if it's not right, we can use the Pythagorean theorem to determine whether the triangle is acute or obtuse. If the squares of both legs are greater, together their sum is greater than the hypotenuse squared, the triangle is acute. But if the squares of both legs is less than the hypotenuse squared, then the triangles are obtuse. And to do this, it's pretty simple. We just square the two smaller numbers because we need to know if there is a potential hypotenuse, that always has to be the biggest side of the triangle. So if you square the two smaller numbers and add them and compare it to the square of the bigger side, we'll be able to tell whether a triangle is acute, obtuse, or right. Now before we do that, we have to make sure that we actually have a triangle. So for example, if you had numbers like 1, 3, and 12 as your three sides, that wouldn't work because we should remember that the two smaller sides of a triangle, if you add them up, have to be bigger than the third side of the triangle. Whether that triangle is acute, right, or obtuse, the two smaller sides always add up to a number bigger than the third side of that triangle. So the first step before figuring out whether a triangle is right, acute, or obtuse is you do have to make sure it can legitimately be a triangle. But once we take care of that, if we square the two smaller sides and add them, we should be able to determine whether it's bigger, smaller, or equal to the hypotenuse squared, what kind of triangle it is. So let's look at some examples. The first one is 6, 8, 10. 6 plus 8 is greater than 10, so we know we have a triangle. And this is a right triangle. 6 squared plus 8 squared is equal to 10 squared, because 36 plus 64 is 100. And 10 squared is 100, so we have a right triangle. But instead of having that side be 6, let's say that side was 7. 7 plus 8 is still greater than 10, so we have a triangle. But when I do 7 squared plus 8 squared, I get 49 plus 64, which is 113. So it's not equal to 10 squared. It's actually greater than what 10 squared is 100. So since the two smaller numbers squared, the two potential legs of a right triangle, are squared and add up to a number that's bigger than the biggest side squared, we get an acute triangle. If I have a 5, 8, 10 triangle, if I add 5 plus 8, I still get a number greater than 10, so I have a triangle. But 5 squared plus 8 squared is 25 plus 64, which is 89. Well, 89 is less than 10 squared, which is 100. So in this case, the squares of the two legs are less than the square of the hypotenuse. So therefore, you have an obtuse triangle. And then the final one would be your example of when something's not a triangle. When something's not a triangle, a lot of times it may look obtuse, but remember, you can't be an obtuse triangle if you're not even a triangle. And 1 plus 8 is clearly not bigger than 10. So that's one, you don't want to write obtuse, you want to write not a triangle, and you do want to distinguish. And that is how we use what we'd call the converse of the Pythagorean theorem, which basically allows us to state that if the sum of the squares of the legs is greater than the square of the hypotenuse, our triangle is acute. If the squares of the legs are equal to the square of the hypotenuse, our triangle is right. And if the squares of the legs are less than the square of the hypotenuse, our triangle is obtuse.